Hi everybody and welcome to my session Structuring the Data Lake. My name is Tillmann Eitelberg. I'm CEO of OH22 Information Services, which is a Microsoft Gold certified partner in Germany. And we have offices in the two locations, Bad Camberg and Königswinter near Bonn. And I'm also really active in the PaaS community in Germany. So I'm the leader of the PaaS chapter in Rhineland. I'm on the board of PaaS Germany as vice president and have organized several conferences like Secret Saturday, Secret Conference, PaaScamp, and so on in Germany. I'm a Microsoft MVP for the Microsoft Data Platform since 8 years, and I'm blogging, or I started blogging again since several years I didn't do that, and now I start again um, on my new blog under decompose.io. So in this session today, I like to talk to you about the data lake and how to structure the data lake um, to get the most out of it. So first of all, I will talk a little bit about why a data lake. After that, we have a small look into the Azure Data Lake Generation 2, and then we check the different data lake structures. So what is possible, what you have to do, why to do that. And at the end, I have two additional demos to show you two different services and functions in the data lake to work with the data. Okay, so let's start with the question, why a data lake, or why do you need a data lake? So to understand why you need a data lake, first of all, we have to clarify what is a data lake. So a data lake is a repository of a variety of enterprise-wide raw information that can be acquired, processed, analyzed, and delivered. And usually it acquires data from different sources. And the data you like to store and like to process on the data lake could be any type of information. It could be structured data, semi-structured data, or completely unstructured data. And the basic principle of a data lake is to store all data, even if you don't know at the moment if it can provide useful information for you. And the idea here is also to store this data without limiting it in the form or in the schema. So if you get data, store it as it is, and then later on you can work with that. And the benefits here of a data lake is that you have no silos. So you can easily ingest petabytes of data into one single repository. Write with multiple applications directly into the data lake. You can have concurrent operation. You have instant elasticity. So if you have multiple workloads, that everything can be handled by a data lake, and it's completely managed. Um, that means that your cloud provider managed the data lake completely for you. You have an enterprise grade SLA. You don't have to care about the storage. And there you have also a clear separation between compute and storage. So usually, um, if you use or if you'd like to store data in a data warehouse, um, always compute and storage is combined. In a data lake, you have a clear separation. If you don't like to query your data, you don't have to use compute power, you just store your data. And this ends in low costs for you. So in most of the data lakes, you can store data for around $20 per terabyte. And this without hardware invests, without licenses, or specific service agreements. You need just store the data, what you need in the data lake. And if you don't need it, you can delete it and then you don't pay for that. Additional benefits are that data is never thrown away because you store the data in the raw format. And especially if you work with big data or in big data environments, you don't know at the moment what do you need out of this data. Are there specific insights available for you? You don't need it at the point if you store the data. And so just store it and you don't have to throw information away, which you may need later on. You don't have to care about the schema. Again, each data source can use whatever schema it likes. Just store it in the data lake. Then you can work with the data directly on the lake, and at the end, the data lake may represent an entity to its fullest, which means that if you store information for an entity from different application, process it in the data lake, combine it, then at the end you have a unified data model with all the information of all entities in your data lake. Again, save the data now, analyze it when you need. You have the possibility to easily extend um, your entities in the data lake. If you need additional fields, additional columns, additional kinds of data, you can just add it later on, and you don't have to take care about when you start with storing the data. In different scenarios, it may also possible that you have the data stored in multiple model forms, which is in a normal data warehouse, you never want to do that. But in a data lake, that may be possible that you store the data in different forms. And with a good data lake structure, you will still have clean data and so that you can easily access from different systems. I mentioned several times a data warehouse. So, and if you work with a data lake, there are different approaches between a data warehouse and a data lake. Normally, in the data warehouse, the data is cleaned and organized into one single schema, and then the data is stored in the database. And your end users have predefined or preformed make preformed analysis on the data, on the created data, so they know what they like to see. And so you have a structure from top down, everything is organized, everything is prepared. And if you need additional information, it's hard to get it in. In a data lake, the incoming data is stored in a raw format. And then if the end user like to um, query the data, like to analyze um, the data is selected according to their respective needs, which means that you don't um, predefine the outcome of the data. You just store it in the right format or in the raw format, and then people can select out of the data what they need for information. Um, Here again, some information about the difference between a data warehouse and a data lake. So usually if you build a data warehouse, it's usually you can measure the data volumes in terabytes. Data lake is more for petabytes or hundreds of petabytes. But at the moment, still we see a lot of modern data warehouse at our customers. And modern data warehouse is typically based on a data lake, and not every modern data warehouse uses petabytes of data. From a data curation perspective, in a data warehouse, you carefully select the data you like to store. In a data lake, store everything, which means also that from the data types, data lake, you have structured, semi-structured, and unstructured data. Where you have in a data warehouse, you usually only have structured data. And that ends that the schema of a data warehouse is carefully predefined. In a data lake, normally the schema is applied on read. And the basic idea behind or what makes it possible to store whatever you like to store is the low cost per gigabyte. So in a data lake, as I mentioned before, you pay like $20 per terabyte. In a data warehouse, Usually each gigabyte count and is really expensive. The data warehouse is stored in a proprietary format, which means if you choose the SQL Server, you store it for sure in like in a star schema, but the data is stored in a proprietary format of the SQL Server. In a data lake, you store everything in files, usually in Parquet files or in CSV files. So um, you can work on the data whichever tool you like. And this happens in no vendor log for a data lake, while you have maybe a vendor log inside of your data warehouse because you can't access it with all tools you like to choose. Okay, let's have a look into the Azure Data Lake Generation 2. So the Azure Data Lake Generation 2 builds on top of the Azure Blob Storage. So before there was a Gen 2, um, these services were completely divided into two different services. So there was the Azure Blob Storage and the Azure Data Lake Storage. And now Microsoft more or less merged these services, and now you can choose between the Azure Blob Storage and the Data Lake Storage Gen 2, which builds on top of the Azure Blob Storage. And the Azure Data Lake Storage Gen 2 combines the best of both worlds together from object storage and um, the file system storage from the Azure Data Lake. And one of the best improvements for the Azure Data Lake Gen 2 was the hierarchical namespace. And just as an example, usually if you have a blob storage, then and you have different folders, the folder names are part of the file names. So if you have thousands of files in one single folder and you like to move these files to another folder, the system has to go through each file and change the name of the folder to the new folder. And with the hierarchical namespace, it's just easy in the hierarchy to change one folder and then each file is directly moved. So this is just a simple example, but this is one of the significant improvements of the data lake Gen 2. You will see that also if you are in the blob storage and create a folder and with the Azure Storage Explorer and you don't put directly a file in it, the folder will be gone automatically if you leave the folder again. So there is no folder without a file in it. Then the Azure Data Lake Gen 2 uses the Hadoop distributed file system, so HDFS. So that means that each Hadoop system or Hadoop compatible system can access the file system or use the same file system, so it can work together with the Azure Data Lake Gen 2. In the older version, so in the Generation 1, the data lake uses a driver which was called Azure Storage Blob Driver or Windows Azure Storage Blob Driver, so the WASB. And now with the new system, it uses the ABFS driver, the Azure Blob File System driver. And this is already part of each Apache Hadoop distribution or Apache project which uses the HDFS. So that's one of the benefits also from the Data Lake Gen 2. And then the complete authorization of the Azure Data Lake is much more better than in Gen 1. So we have POSIX permissions for directory and individual files. And together with the blob storage part, you now have the possibility to connect to an Azure Data Lake through the Azure Active Directory OAuth Vera tokens, but also you can authenticate via shared keys, so what you can do on a blob storage. Then if you create an Azure Data Lake Gen 2, so you have your own URI schema to address resources. So usually at the beginning you have your schema identifier or the protocol, which is ABFS or ABFSS if you are using TSL connections. And after that you have your file system, so which is containers in Azure blobs. So this is the name of the container or the name of the file system. And then you have your account name, which is the name of your storage account, followed by .dfs.core.windows.net. And then you have your path and your file name and your complete directory structure separated by slashes. The file name for sure is optional when you are referring directly to a directory, which you can often do, or which you often do if you maybe load package files or something like that from a folder, so that you're just addressing the directory and not the one single file. The Azure Storage offers different access tiers. So an access tier is how fast you can get your data, and with that, how are the costs of storing the data. So the slowest one and the cheapest one is the archive storage. After that, you have the cold storage, the hot storage, and since November, you have the premium storage, which is since November in public preview. So usually you're using hot storage, and there you're adding your data. And if you don't use the data on a regular basis, you can move it from hot to cold, and after that from cold to archive. And so the data storage is cheaper, but also you have to pay more for accessing the data. So just store it is cheaper, but access it, read access or read and write access is cost more, and just store it is really cheap. And then you also have different redundancy levels, and this is something which is important. More and more data you have inside of your data lake. So often companies are asking how to back up the data in the Azure Data Lake. And if you have terabytes or petabytes of data in your data lake, to store all this data somewhere else is not often a good solution. And for that, what you can do is you can have different redundant storage to store the data automatically, maybe in a different zone in the data center with zone redundant storage, or different geolocation with geo-redundant storage, or you can also store geo-zone redundant storage and so on. So this does not mean that if you have some of these redundancies that you never need a backup, but it may be that for some use cases is help to not back up all of the data inside your Azure Data Lake Gen 2. Okay, then let's have a look into the Azure Data Lake and how we can create it in Azure. Okay, now let's create a simple Azure Data Lake Gen 2 in Azure. As you can see here, I'm in the Azure portal and in my resource group DPS 2020. And here I just click on Create Resource. After that, I select Storage Account. And then I have to define the basic information for my new storage account. The subscription is already selected. My resource group is loading or is also selected at the moment. It's DPS 2020. And then I define a name for my storage account. The name will be DLS for Data Lake Storage. This is based on the naming convention of the Cloud Adoption Framework. And after that, I define the project name, which is here now DPS 2020. Then I select my location. I will put this into West Europe. My performance tier is standard. I will create a storage v2 account, and I set my replication to local redundant storage, because here for the demo, another replication is not necessary. Then I click on networking. On networking, I usually have the possibility to put this data lake into a specific network or into a private endpoint. But here also for this demo, I will use the public endpoint. So I have access from all networks to this data lake storage. Then under data protection, I have a lot of new possibilities for a storage account. But most of the possibilities are not, you can't use them together with an enabled hierarchical namespace. So the only thing here you can use with the hierarchical namespace is the soft delete for file shares. So I will not enable any of these properties here. And the next part, now this is the important part here, to create a data lake storage generation 2 is to activate the hierarchical namespace. I set this to enable, just click next, and now I can define tags for my resource. Normally we add a minimum set of tags to each resource we create in Azure. This is the owner, project, customer, and status. But because it takes me a longer time, I will leave that here empty and just say create or review and create, and then I create the storage account. And now it takes some seconds to create the storage account, and then I can directly access the storage account in the Azure portal and can upload files to it, create folders, and so on. So after the deployment is completed, I can here go to my resource and can now go to containers and create a simple container. I will call it just raw, and the container will be created directly on my file system. I can now just open my container, select upload, and select a file from my local storage. I will just upload here my data CSV file. And then the data is there, and I can access it here through the portal and see information of the data. So let's talk now about the data lake structure. So the first question is, why do we need a data lake structure? So the idea behind the data lake is store unstructured data, but do not store data unstructured. So one thing what you have to avoid always is to create a data swamp. So this is something which is a term for a data lake. So a data swamp is if you have relevant data, but it's difficult to locate it due to broken relationships, missing metadata, or just simple poor organization. And because the data lake itself does not prevent you for just a big storage of disorganized files. So you have to make sure that you know information, or you have information about your data, so that you need metadata, that you have a good schema for your data, and so this is the only thing how you can make it easy to query the data inside of the lake. So as I said before, it's a um, schema by read or something like that. But for that, information. It's not like select star from my file and you get everything what you need. So you need information of your data lake and of the files stored inside your data lake. If you have inconsistencies in your data, then it will be hard to analyze the data. Even if your users are highly skilled data analysts, they need information about the data. And if you don't have a proper governance, if you don't have access controls, and so on, then you can also get privacy problems. You can get different issues inside of your data lake. And what you like, again, to avoid is a data swamp, that data or the data lake just is a zone for just dumping data, and which is never analyzed or mined for insights. So that's the complete opposite of what you like to get with a data lake, that you like to store data, unstructured data, but in a form that you are able to analyze the data, that you have actual information about the data, and that you are able to mine these data for new insights. And typical characteristics for data swarms are too much data without any organization. So just storing the data inside the lake. Then missing meta information of structured or unstructured data. So if you have a lot of unstructured data, but you don't know something about that, where it comes from, who provided the data, or something like that, this is missing meta information, then this is a problem of your data lake. Outdated data. So make sure to update data which is stored in the data lake, or even you can add metadata to it so that you know that a specific file is maybe from 2010 or 2012, but it's not the current file. Missing or wrong timestamps, lack of active management, no regular cleanup of the data lake, missing or broken relationships between information, and one thing which is for each IT system, a typical characteristic for a bad IT system is a poor documentation. So these are, I think, a lot of typical characteristics if you have a system not properly set up. But especially here in the data lake, make sure that these things are organized and documented. Other way, you just store data and you will never get good information out of the data. This is a screenshot of, or a small picture of Colibra, where they just try to visualize a little bit the difference between the data lake and the data swamp. So it's like a clean lake and a lake where are some, yeah, um, waste in it. And so this is just as an information. There's another picture here from medium.com where you can also see um, some problems inside the lake. Um, and a data swamp has no value for you and for your teams. It's yeah, everything if you what you store in the data swamp at the end, you can delete it directly because it makes no sense for you. So try to avoid that. Structure your data, as you can see here, metadata management, directories, subdirectories, tags, etc. Everything what your data lake has, use it to build a proper data lake. And this is how to prevent or how to avoid a data swamp. What we usually do for that is we try to organize our data into zones. So just to make clear, there is no single blueprint for every data lake. There are different concepts of zones, and often they are called differently, but have the same purpose conceptually. And a zone is something how you store the data in your lake during the processing. Um, so it's often our zones are categorizing the data based on a state inside the lake or a characteristic in terms of business value or consumer access. And if you're then moving the data through the lake, you're moving the data from one zone to another zone, and that happens during the processing of the data. So this is one simple picture from dzone where you see that there's a transient zone, which is for ingest, for tagging the data. You can build a catalog on top of the data. Then you have a raw zone where you apply especially metadata, trusted zone where you have data quality and validation processes. And at the end, you have a refined zone where you enrich the data, you have automated workflows, and then you push the data to the consumer systems so that the end user can use the data. But this is still one example of the zone concept inside of a data lake. Another concept is something like this. You have an intake tier, management tier, the consumption tier, and then inside of these tiers, you are working with zones. You have the source system zone, transient zone, a raw zone again. So you see that again, the same names than the picture before, but you see also different names like integration enrichment, data hub, and data discovery, and so on. And so this is just another picture for the data lake zones. Here's something which we often use also inside our data lake, so with the raw zones and curated zone. But what we use at the moment more often in our projects is this zone concept, where we have a raw zone and then we have different sections inside the zone, similar to the second picture. Um, with the tiers here, we are using zones and sections. There was tiers and zones, but this is yeah. At the end, this is what we are using at the moment in most projects. So we have a raw zone, and we have a quality zone and a curated zone. And the raw zone is in most of the projects the uh, ingest part in the source sections, where the data is getting in. Then we validate the data, and we are moving the data through the sections and then from one zone to another zone. And at the end, the consumption section is where the end user is working on. Additionally, we have a sandbox zone, and the sandbox zone, or the sandbox itself, is going over each zone. This is a special zone for the um, data analysts, for the data scientists, because often they need the raw data, but also data in different states. So they need access to all of the different zones to do the analysis, to build up new ML models. And so for that, we have the sandbox part. As you can see here, so I've added two additional zones here. So the staging and the sandbox zone. The staging zone is often not directly inside of our zone concept, but we often have something like the staging zone. So if you're working, as an example, with D365 CE, there's an export for CDM, and so for the common data model, and this data is pushed directly on a data lake. And in the future, also D365 F&O will have this feature, so to export data and to synchronize data directly into a data lake in the common data model. And this is something where we need a data lake. And for that, we are using this as a staging zone. And then we take the data from the staging zone into our raw zone. And this is the real entry level of our data lake inside the project. Um, and then we are starting copy the data from there to the other zones. And as you can see here in the synonyms, we often hear other synonyms for these zones like intake, landing, source, or if you work with Databricks, you will also hear the names bronze, silver, and gold for the different zones. Then we have our quality zone, and the quality zone is this area in our data lake um, where we correct the data, enrich the data, and yeah, where we try to where we build the most of our transformation and integration steps for the data. And the third zone, the curated zone, um, this is the data or the zone where the data will be provisioned to the consumers. So here the data is curated and offers the best value for the consumer, so they can easily access the data, and the data is also customized here for the end user and the system. So if you remember, um, in one of the first chapters, I talked about that data can be duplicated, or data can be stored in different formats for the end user. And this happens here in this zone, so that we provide in this zone specific entities um, customized for the need of an end user or their systems. And then again, we have the sandbox, and this is also at some projects called laboratory, and this is for the data scientists to make deep analysis or deep analytics on the data. Here, additionally, for the zones, as a concept how people can access it and where we have which governance and which data process. So usually um, for the first three zones, um, we have no access for users. So for sure, a data engineer who develops the systems, um, he should have access to work with that. But in the production environment, only the processes, the automatic processes, maybe in Azure Data Factory or something like that, should have access to these zones. Yeah, so then you work with staging raw quality. Only these processes have access to it. And the created there, the user, so the end user, should have full read access, but by role, which means that you can give different roles different access to different data. And for the sandbox, yeah, there should be read and write access. But um, this is a little bit mixed information because the data scientists need read access on the different zones, but only write access to his sandbox so that he or she can read data from a staging a raw quality zone, but write the data and the information he get out of the data only in the sandbox. So from a governance perspective, we on the staging area we have usually none governance, because this data is only exported from external, from third-party systems, and then we have basic governance on raw, full on quality, full on curated, and so this is the process for the governance. And at the end, you see also where we have the data processing. Um, so we don't process any data in the staging zone, but we have minimal processing in raw, heavy in quality, none curated, and also again minimal um, in the sandbox, but based on what the user, the data scientist, is doing with the data. Then before I talked about a little bit about the sections, and this is something we have in our projects as an additional structuring layer. And we usually use the sections as an additional step for the data processing. So if we do data processing, we move the data through the sections. Um, yeah, we have the same authorization concept here as for zones. So if we have no user access um, in the raw zone, we also have no user access in the different sections. So this is the same concept as in the zones itself. So one important thing then, or an additional important thing, is the folder structure. So the zones are often um, not directly related to the folder structure. Often in projects, zones are based on the containers or the file system inside of the lake. And after that, you have the sections. That is the first folder. But in some projects, you have one file system and starting with a folder called raw for the zone. But this is something you have to figure out in your project what is the best, what fits best for you. What we believe is that a folder structure should have a human readable, understandable, consistent, self-documenting naming convention. So what we often see in projects where we came in, that there are naming conventions which are not human readable and not understandable. You don't know exactly why the data is there, and you have to read the documentation to understand why data is stored in this folder. And the best thing we believe is to store the data human readable and understandable without an external documentation. So it should be really self-documenting. And then the zone may be organized by sections, source system, and then the entity. So here we start with the zone. Maybe this is a file system or a folder. But after that, we will have definitely a folder section. And then we have the different data sources as folders. So if you have Dynamic CE, there will be a folder in the raw zone, maybe um, for D365 CE, and maybe an additional folder for D365 F&O. And then you have the entities inside, so customer, product, and so on. And after that, we store the data based on the timestamp. So first the year, then the month, then the date, and at the end, the file name and the extensions. Um, yeah, as I mentioned, in some environments, the zone is a file system, but important here is that also sometimes the exact timestamp is displayed more granular in the folder structure. So there are systems where you ingest data in such a high frequency that the DD for the day is not the end of the folder structure. Maybe that you will here have additional folders for the hours and the minutes. And yeah, keep in mind that the folder structure should be human readable and consistent. So do it in each, maybe in each zone, the same structure. But again, as for the folders, there is no one um, blueprint which you can choose in each project. Um, Maybe that you have to discuss it in a project and change it a little bit. In further zones and sections, it may also be possible that the source system is no longer part of the folder structures. Because if you remember that I mentioned that an entity at the end will build out of different source systems. So then maybe you have an entity customer and you build it together with different source systems. Then at some point, the data sources will no part of the source systems because the entity now is then a complete new entity which you build in your project, in your modern data warehouse on this data lake. So additional to the folder structure, to the zones, to the sections, I often mentioned the term metadata. And this is something which is also really important to structure the data lake. So we define three different categories of metadata. So the first thing is technical metadata, where you have a schema name, a table name, field name, and so on. And then you have business metadata, which means the data owner, the data source, maybe the privacy level. And then you have operational metadata, so the timestamp, the size of data, the lineage. And these three different categories of metadata you have to define upfront and try to store this information to each of your files inside of your lake. Maybe that at some point, some of these information can be extracted out of the folder name, so of the folder structure, but based on the data lake you're using, you can store these information also directly to a file. But usually, if you try to store additional metadata, you have to use an additional service to store all of these different metadata. And for that, there are different data catalogs. So there are metadata catalogs and data catalogs. And normally, a data catalog has much more information for the data and but it has underlying a metadata catalog. And some data catalogs you can use as an example is the Azure Data Catalog. So it's a Azure Data Catalog Generation 1. This already exists in Azure. Often, if we use this catalog at customers, they are missing a lot of functionalities. And yes, they are right. The Azure Data Catalog is missing really a lot of different functionalities. But on the other hand, it has really good features. And to start with a proper data lake and a good structured data lake, it's better to use the Azure Data Catalog instead of using nothing. And here you can store metadata, you can store information, you can document your data. But at some point, it's It's missing functionalities, but use it. It's a good service, and it's really for you. If you start a project, it's really fast to deploy in your environment, and it's cheap. Um, Additional data catalogs are Apache Atlas. It's an open source project. Then you have Colibra or Informatica as third-party data catalogs, but they're not so cheap. So um, check them out. Maybe that helps in your project. It's better to use one of these data catalogs instead of using nothing. Um, And for the data catalogs, just an information, there are also some specialized data catalogs. So if you're handling geodata, there are also some specialized data catalogs just for geo information or for geodata. If you're using the Azure Data Lake as your data lake, then this service provides direct support for storing some of the metadata. Um, Here, technical metadata are directly generated and stored as file properties. So these are not only technical, it's also operational metadata. So here you have your the name of your file, um, but you also have information like the type, the size, the access tier. So these are more operational metadata. So we have both a little bit mixed. But if you need more metadata, then you can write these metadata to your files via key value pairs. This is what you see in the screenshot at the end. There you can add additional metadata just as key value pairs. You can add them directly in the portal, or you can add them later on through additional tools like PowerShell. So let's have a look into this in our second demo, and now we can check how you can view and edit metadata. Okay, now let's have a quick look into the metadata of a file. So I just created a new folder data and will upload a single file to it. And if you then click on the file, you will see the metadata of this file. And we have two types of metadata. We have the properties with like the technical metadata, where you see the last modification date, the creation time, and we have the metadata as a key value pair. I can here go into this and add some information. I will now create two different types of metadata key value pairs, conference and author. And if I leave this and go back to that, you will see, okay, it's still there because the metadata is now directly stored at the file. And now you are able to work with this metadata. So you can choose PowerShell as an example to work with that. For that, I just created a PowerShell notebook inside of Azure Data Studio. And now I will just get here some information out of my file. So I use get AZ data lake gen 2 item commandlet, and I will get information here like the owner, the default scope, and so on, and also my metadata. So last modification date, created time. I see like content hash, and here I see my key value pairs. Now I'm able to work with these key value pairs. I can select them, I can update them. But that's important. If you like to update these fields together are an object, which means if I update just my metadata with conference DPS 2021, the PowerShell commandlet will update these fields. But if I now go into my pane and refresh the data, you will see that I only have one key value pair there, because the metadata, again, is a complete object, and each time you have to update all the key value pairs. If you miss something, it's like you delete this key value pair. So at the end, I will have two additional demos. So let's see how Azure services and function can help us to keep an eye on our data lake. So structured data lake does not only means to have a good concept for zones, sections, and the file structure. It also means that you need information for your of your data. So to have something how you can monitor your Azure storage, so Azure Data Lake, and something which can also help you to work maybe or not maybe to work with different access tiers. So the first demo is about um, Azure Storage Monitoring. So to show you how you can monitor your data lake with the Azure Monitor and the built-in tools of Azure.
So if you talk about structuring the data lake, one important part is the monitoring. So how to keep an eye on your data lake to see what happens, what is the ingress, what is the egress of the data. And if you go directly to the overview of your data lake, you will see some charts here. If you'd like to have more information about these charts, on the left side, you can scroll a little bit down. And under monitoring, you see the part insights. And here you see these charts a little bit bigger, and then you can see directly um, for the different charts the transaction by API name, the availability of your storage account. So you see different metrics and get an understanding what happens on your storage account. And all of these information come out of Workbox. So if you go on the left side to Workbox, you will see um, here under Insights, already pre-existing um, workbooks and storage account overview is what we saw before under Insights. And now go as an example to performance. I will see a chart or a workbook for my performance counters of the data. Scroll a little bit down. Here you can see for the different namespaces how um, was the latency here, and so the different metrics of your lake. An additional part on how to monitor the storage account is the classic part. But this is typically if you create a new data lake, not activated. So if you go to diagnostic settings, I already activated that. You can just click here on, and then you can um, configure the diagnostic settings for the different properties of your storage account, like block properties, file properties, and so on. The important part is that the logging version you have to set um, to the version 2, and then you can also get this information um, into your logging file. Logging file, that's thing here. If you activate that, I go now back to the overview and then to my containers, you will see that there's an additional folder which is called $logs. Go into this folder, can go to blob, and then you can see a structure like I mentioned before, how to structure data on a lake. You can just go here, and here's different log files. I can go to a log file and click on edit, and then you will see that this is a CSV file, and that you see directly with the information about get block metadata, list blobs, get block properties, and so on. Get all the information, what happens directly on your lake, which APIs should be used, and so on. And you can use this metadata, or sorry, not the metadata, you can use this information from the log file, the CSV file imported in Power BI, somewhere else to get your information out of it and to have good monitoring.
Okay, and the second demo now is how to use lifecycle management of the Azure Data Lake storage, or not the Azure Blob Storage, the Azure Data Lake storage, but how to choose the lifecycle management for the different access tiers.
Okay, in this last demo, I want to show you one really cool new feature of the Azure Data Lake storage. As I mentioned before, there are different access tiers, and each access tier has different prices. And so now the question is how to move data or how to decide which data has to be in cold storage and which data has to be in archive storage or in hot storage. And for that, the data lake storage has a functionality which is called lifecycle management. If I click here on lifecycle management, I can define different rules. And the rule I like to define here is now archive data. So I will do that not for all blobs in my storage account. I want to add a filter to that. I go next. Then the filter is last modified. And here I'll just say 60 days. And after 60 days, I want to move my data to an archive storage. Then I click next. I can say, okay, this should only happen for raw data. Say add. And now I have created a rule inside my lifecycle management so that each data, each file in my raw data storage will automatically move to a cheaper storage if it was not modified in the last 60 days.
Okay, so thank you very much. That was from my side. I hope you enjoyed the session. And yes, thank you very much. Special thanks here to Microsoft for supporting the Data Platform Geeks and the SQL Server Geeks community. And if you like to win some prizes, post a selfie with the hashtag DPS2020 and give session conference feedback, visit the sponsors and exhibitors. And yeah, thanks again, and hope to see you somewhere else on another conference. Bye bye.